Week 4, and let's get started. So, announcements. So, mini project 1, Cal Finance, is due next Friday. There's a checkpoint 1 this Friday, and you don't need to submit anything for this checkpoint. This checkpoint is just for you to stay on track. So, if you're able to get to checkpoint 1 by this Friday, you are pretty good. And so, checkpoint 2 is due next Friday, and that is the whole project in itself. So, if you need help with the project, we have office hours this week on every Thursdays, and you also can come to office hours next week as well. And if you're not on office hours or you can't make it, feel free to ask on the mini project 1 ed thread. Right now, it's pretty silent on there, so if you do have questions, please don't be afraid to ask. So the grade sheet that we set up last week should be up to date to today, excluding homework 1 attendance, homework 1 grade and homework 1 slip days. So if you have any discrepancies, please let us know via private post on Ed. All right, and again, if you have any feedback on today's lecture, please let us know in the attendance form. Okay, so before we get started into today's topics, we're going to talk about, just for kind of review about what we did in lectures 2 and lectures 3. So for data flow, we talked about our fundamental motivation was modifying properties on structs. So given this example right here, we have this variable numTaps and it's set to 0. And we have in the body this button that when we tap on it, we want to increment numTaps by 1. Now, if we do this, if we recall that this is not possible because the compiler will throw this error saying left side of mutating operator isn't mutable. Self is not mutable, immutable. Self is immutable. And the reason for this is because it's not able to differentiate whether the variable that's declaring this content view is it's a var or is it a let. So you cannot mutate any properties within a struct by default. So regular struct properties cannot be mutated within our own structs. So how do we mutate these properties? So to be able to circumvent this, we basically simply add a @state property wrapper onto this property. And what this does is that it delegates the storage or handling of numTaps to SwiftUI. So SwiftUI is going to handle numTaps for us. And the variable is now allocated to a separate portion of memory handled by SwiftUI. And whenever this variable changes or updates, since it is an @state, it will re-render the view if there are any dependencies. So since in this view, we have this numTaps right here, when I press on it, it will increment numTaps by 1. And if we show numTaps here, for example, then since there's a dependency, SwiftUI will re-render view to update or reflect the new value. And it's really efficient because SwiftUI only re-renders the views that are, again, using the @state variables, which we call dependencies. So this right here creates a dependency with numTaps because the view itself, or somewhere in the view UI, references numTaps. So when I tap on this button, it's going to increment numTaps by 1. And again, since there's a dependency with the view and this variable, SwiftUI will re-render the view to update the new value of numTaps. And if we do this again, numTaps will be incremented to 2 now, and then we will reflect the new UI. So for the next property wrapper is @binding. And the reason for this @binding is when we want to sync up a variable in its parent view to its child view. So for example, here we have these two content views. We have this incremental button view right here, and this is incremental button. We basically want to pass numTaps into incremental button. And incremental button has the UI where we basically click the button and we'll increment numTaps. And so our goal here is that when we click on incremental button, we want to update this numTaps, that this is the source of truth. So that's why, when we see an at state, we call it a source of truth because that is the original location of the data. So the issue here is that since we have an at state on incrementables, buttons, numtaps, what this does is that it creates two places in memory for numtaps. So again, we want to sync up incrementables, buttons, numtaps to content views numtaps. But since this numtaps is at state, it initializes new variable in memory. So we have two places in memory where SwiftUI is managing it. So if I increment this, if I tap the button here, I will only increment this numtaps, right? Incrementable buttons numtaps, but not the content views numtaps. So I want to find, we need to find a way so that we could sync up the numtaps here to this. Does this make sense? Cool. So the solution to this is that we create a binding. So instead of annotating this numtaps with an at state property wrapper, we do it with an at binding. And what this does is that this numtaps within incrementable button has not only read permission, so we could get the value of numtaps here, but we could also write back to it. So whenever I click on this button right here, numtaps plus equals 1, what that does is that it will actually increment this numtaps by 1. So these two numtaps, these variables are synced to each other. And the place or original location of this numtaps is located in content view. Now, we cannot just pass a regular numtaps. We have to add this $ onto numtaps to pass a binding. Because without this $, what we're doing is we're just passing an integer, and it won't work. So when you pass this $, or prepend this $ to numtaps, so that, hey, we're saying, I want you to pass the binding version of this numtaps so that we could write back to it as well. Any questions about this? Okay, cool. So at states, again, allow value type variables to re-render views when changed. So all of our views are structs that can't be changed by default. So to circumnavigate that, we annotate the variables within our structs as at state for SwiftUI. And what that does is that it hands off property control to SwiftUI so that it remains in memory for the lifetime of the view. If the value changes, SwiftUI will reload the view with the updated data. And it's great for simple properties that belong to that specific view. For example, let's say your app has you have a list of people and you want to edit like a person's information. So to change or to show that sheet for the edit view, you could use an at state variable on that, I guess, main list view so that when you click on a button for example, to edit the people, it will flip or toggle that variable and it will show the sheet. So a good kind of common practice is to use the private keyword to specifically limit the access scope. So for those at state variables, they're only concerned with the view itself, right? No other view needs to know about the variable that is concerning about showing the sheet for my list view, right? So if you use the private keyword, so you do at state private var, whatever your variable name is, then that variable is only locked into that view. So no other views can modify or read that variable. So that's a good common practice. And again, it declares a value type as a source of truth. So that's the original location of the data. And then at binding allows a child view to read and write from and to a at state variable or source of truth in its parent view. So, I think I forgot to update this slide. But you get the point of at binding, sorry. Okay, any questions with data flow? Does that make sense? Are you guys clear with that? Okay. All right, we're gonna just run through this really quickly. Hopefully you guys have again, good understanding of what value semantics versus reference semantics are. So structs conform to value semantics. So what this means is that whenever I assign a new variable to a struct, or I pass a struct instance as an argument into a function, it gets copied. So for example, here, when I do Kaylee2.occupation equals accountant, what I'm doing is that I'm modifying the copied version of Kaylee. So there's two places in memory where this happens. So we're modifying Kaylee's two's occupation property to be account, but we're leaving Kaylee's account occupation to be the same. So we get singer and we get account. So for classes, again, they conform to reference semantics. So when we assign a new variable to a class instance, or when we pass a class instance into a function, what we're doing is that we're not creating copies, we're passing references around. So when we do Kaylee2 occupation equals accountant, we're actually modifying this Kaylee's occupation property. So now both of them will be accountants. So here's a more with a diagram kind of view here. So we have Kaylee, and then when we do Kaylee2 occupation equals accountant, we create a new copy of the original Kaylee, and we're modifying the occupation property of Kaylee2 of the copy. In contrast with classes, we have Kaylee and Kaylee2. Kaylee2 points to the original data of Kaylee. And when we do Kaylee2.occupation equals account, we're actually modifying the original Kaylee's occupation property right there. So they both are account. All right, so that was a quick review of data flow and value versus reference semantics. Now let's talk about this framework called observation. So at state does not work with reference types. So when we've seen before with numtaps, that is an integer. Swift primitives like integers, doubles, strings, dictionaries, arrays, all of those data types they conform to value semantics. But for classes, at state doesn't work. So upon changes to reference types properties, it does not reflect the change. So if we instead use a class to declare a student, for example, and we create a at state variable called student, and we initialize it to some student instance right here. And then here in our button, we want to change the student major to, for example, like anthropology. When I click the change major button, nothing changes. The content views bodies does not update. And that's because student is a reference type. It's a class. And again, I'm not exactly sure why of the details, why this doesn't work, but for I guess, how SwiftUI is designed, the classes or reference types do not work with that state. So to circumvent that, we use a framework called observation that was introduced in iOS 17, and it provides the following capabilities. You can mark a class type as observable. And what that does or allows you to do is that you can track changes within an instance of an observable type, and you can observe or utilize those changes elsewhere, like in UI. So it basically brings the at state property wrapper abilities that we have seen with values with instances that conform to value semantics to reference semantics. So it allows reference types like classes to act like at state that we've seen before on value types. And again, with at state, you're creating a source of truth, like always. So with this observation framework, we kind of want to hone into our dependency definition. So a view forms a dependency on an observable data model object when the view's body property reads a property of the object. So what that means is that if within a view's, or like, for example, your view's body property, there is some variable that you're using or a property that you're using from the observable data model object, then it forms a dependency with that object, like we've seen before. So if not, then the view doesn't track any dependencies. And for all dependencies, if the tracked property changes, SwiftUI will update the respective view for that. And if other properties change that the body doesn't read, the view is unaffected and avoids any unnecessary updates. You could also support tracking of computed properties that make use of an observable property. And we'll take a look at what computed properties are in a demo later. All right. So here, let me just try to get out of here. So here I have the sample project. And here I have this class right here, and you can see it is a book, and I conformed it to identifiable. And here we have this, it has a title, it has an author, and it has a variable that simply states if it's available or not. And then here we have a constructor for this class. Now, what I want to do is to make this observable. So I want to make this class or any book to be observable. So what I could do is that I could basically use the observable macro. And what this does behind the scenes is that it will simply inject, I guess, code into this class so that it is observable. So what this means is that I can use this book as an at state within my SwiftUI views. So let's see. Let me see if I have. Okay, so we'll just continue with the slides for now. Okay. So observation tracks changes to any observable property that appears in the execution scope of view's body's property. It can also share an observable object to other views. So you could pass an observable object to, for example, a subview. And the receiving view form a dependency if, again, if it reads any properties of that object in its body. And you could pass that, for example, that book, since it's observable, you could pass it through multiple layers of view hierarchies. So you could pass it through a subview and its subview without each immediate view forming a dependency. So only if you're reading or mutating a property of that observable object, then you form a dependency. But if you're just passing that object itself through, like, for example, a view or subview, then you're not forming a dependency. Only if you're reading in properties. So we talked about at binding, right? Now there's something similar for observable objects. So in places where an at binding is expected, you could wrap the model data with at bindable. I know this is a bit confusing, but I'll show an example later on. So you're able to mutate an observable object's properties as like a binding itself, and it can exist outside a SwiftUI view for some circumstances. So for example, here we have the struct, which is a book edit view, and here it has a text field, right? And a text field has this property, or sorry, has this parameter which accepts a binding, a string binding. And on our book property, we have this title, which is of type string. And again, this is an observable object. Why? Because we annotate it with an at observable syntax, which I'll explain what it is later on. And that makes it as an observable object. And so if I want for this text field, if I want the user to type anything within this text field and modify the title property of this book, what I could do is I could just simply annotate this as an at bindable and property wrapper. And now I could use it just like a binding in itself. So I use $book.title. What this does, again, when the user types within the text field, it will directly write to the book's title property for this observable object. Again, it's a bit weird, but I'll show you an example later on. We are not going to do that for now. So the next kind of section, I'm going to talk about what macros are. If you have taken 61A, you probably are familiar with macros. But for a general overview of how code in your computer gets run, you first have your program text, right? This is your Swift files. This is your SwiftUI files. These are all your files, right? And to a computer at first, it's just text. It's just sequences of characters, spaces, white spaces, and so forth, right? It has no meaning to the computer. And then it goes through, the computer takes this program or the code that you've written, and it inputs it into a program called a compiler. And so a compiler is a program that translates your code, which is your text files, into machine code. So what this means is that it translates your code that all is just characters into something called assembly, which is a really low level form of a language that a CPU can understand. And eventually it will outputs binary, which is just ones and zeros to the CPU. And okay, so it goes through a compiler, you get the machine code, and then it also creates a an executable that you could run your program that's per operating system specific and so forth. But that is just kind of the general pipeline of how your code gets run. So macros add slash generate hidden code. So the difference between property wrappers is that macros generate that part of the code at compile time, so before the code gets run, whereas property wrappers execute during when the program is running. So it adds new code alongside the code that you wrote, but it never modifies or deletes your current code. So observable is a macro. So it takes your source code, basically the code that you've written, and it injects additional code within that, but it never modifies what you had prior. So it just simply, you know, so okay, so the source code, okay, so during the compiler, it represents your code as an abstract syntax tree. So if you have taken 61A, hopefully you have familiar with a tree data structure. So it represents your source code as a tree. And within that tree, the macro, or before the compiler, there's this program called a preprocessor that expands those macros. So it looks at to see if there are any available macros, and then it will inject the appropriate, I guess, nodes within the tree, and that is will become your expanded source code that goes through the rest of your compiler stages. Again, this is a bit more technical, but this is how macros work. It just adds, you can just think of it as adding code that someone else wrote, in this case, Apple wrote, into your program before the program gets run. So if you right click, for example, at observable and you click on expand macro, this is what you see. This is what Xcode with compiler injects into your code. So if you, again, take a look at again, if you expand macro, all of this additional code is being injected when the program gets compiled. All right. So the next kind of main concept is MVVM. And MVVM stands for Model View vModel. And it's an architectural pattern that facilitates the separation of UI from backend business logic to the rest of your app. So, for example, you first have your model, and your model is simply a representation of your data. What is it? So, for example, in our example before, this model would be our book class. You might have a person struct, you might have a person like a class game manager or struct car. Your model is a representation of your data, and that's usually your classes and structs. And then next we have our view. And our view part is simply your Swift UI views, right? That's just the UI that you display to the user. And then within the middle of it, that's facilitating between the model and the view is what we call our view model. And the view model is where we locate or put all of our main data that drives our views and also any helper functions that the view might need to interact with that data. So for example, in our view model, we might, for example, let's say we're creating a game. Our view model might be our game manager, and our model would be a player, for example, a struct player. And then within our view model, we are creating multiple instances of our player. So how many people are playing our game, we create those player objects within the view model. And let's say, for example, in the view, we have a button that allows the user to attack another user. So when I click on that button, what I could do is that I can call a function on the view model that does some computation with the two objects or two players involved. So what this does is that it creates a separation of logic, right? The view should only display UI. It should never be concerned with displaying or doing computations or figuring out what does that or what does what. It should only show the UI. Whereas the view model, it contains instances of our model objects, and it creates a endpoints that our view can tap into to modify our instances. So again, like for example, we have a struct player, and then a view model is our game manager that contains our player instances, and we create functions within our game manager that are exposed to game view. For example, when I click the attack button, I call game manager.attack and then those two players, and it will do the computation within game manager itself. So again, we're separation of logic here. So you can convert a general template. So if you have a project that you have currently, you can convert to MVVM using the following ways. The models will stay the same. There's nothing you need to change about the models, right? You want to move all the business logic from our views into a manager, and that's our view model. So if you have in your view code that, again, does computation, heavy computation, you're fetching from a server, or you're doing networking, or you're doing something that saves data to locally or a database, you want to move that all that logic away from our views into our view model. All at state variables within reviews should be only pertinent to the views themselves. Again, for example, an at state that toggles or a boolean that displays whenever I should show an edit sheet or not, or if, for example, I'm doing some animation work and I have some at state variables that basically keep track of where the user has dragged a view to somewhere else, like the position. So only variables that are related to the views themselves or the UI themselves should only be in the SwiftUI views. Everything else, you should put it away into our view model. And our view model should be a class, not a struct. So our view model should conform to reference semantics so that we can pass a reference to our subviews rather than copies. So what this means is that by annotating or by creating our view model as a class, when a subview wants or requires that view model, we can just pass it directly, and it references the original instance or view model instance that we have created. If it was a struct, if we pass a view model around, it will create copies. So what that means is that your subviews might have a different, it might read a different data than what another parent view is reading. So since we want our view model to be synced up within all of our subviews, that should be a class, not a struct. So there are multiple ways that you could share model data within a view hierarchy. So you could pass an object to each view in your view hierarchy. So what this means is that, let's say you have a parent view, you have a subview. So for example, A, B, C, D, where B is a subview of A, C is a subview of B and A. So what you could do is that you could basically pass a variable or object with an A down to B, and then B down to C, and then C down to D, right? This is probably you have seen in lecture 3, or you have seen in mini project 1 already. And this is convenient if you only have a shallow view hierarchy. So this is really convenient if you only have like two, like you have a parent and a subview, or maybe even three, right? Three views together. But it gets complicated when you have a lot of subviews and you want to pass that object down to the very bottom. So what you could do is that you could add that object to the view's environment. So what is an environment? So each view has an environment, and that is basically some system-wide settings that each view has. So for example, you could get if whether a view is in dark mode or light mode, you can get the orientation of the device. You can also get functions like dismiss so that you can dismiss a sheet as well. And so views inherit environment from its parent view unless you want to override any values using the dot environment modifier. So if you, for example, on B, if you pass in for example, a object through its environment, then you can get it all the way down to subviews D, because D inherits from C and C inherits environment from B and so forth. Again, I'll make sure that it makes a bit more sense. So, but yeah, so what this means is that if you have a lot of subviews and you want to pass some data from the parent view all the way down to its lowest child view, it's better to use environment than passing it one by one by one by one. All right, so let's go through, take a look back at our demo again. So here we have, again, our class book. It is an at observable. And what this means is that I can use it like an at state. So let's go to our content view here. Let's just not worry about this for the minute, and let's just create a book. So this is my book here. Again, we don't worry about this for a minute. And then here I have this button that I'll create here. And let's see here. We simply want to change the author to, for example, to an author like this. And then here we just display the book's title. Now, if I just had this without observable and this was just a struct, and if I try to, sorry, let me, okay. Let's go back to our content view. Let's see if it loads. Okay. So as you can see here, we have this, okay, let me just comment this out. Okay, that was an error too as well. So let me see if it reloads. Yeah, sorry. Sometimes switch by previews, it takes a bit of time for it to get started. So, okay, so here we have our button, sample book title. If I click on it, nothing happens, right? Nothing gets updated. The reason why is because book here is a struct, okay? Again, at state property wrappers do not work on value semantics or objects that conform to value semantics. And since structs conform to value semantics, it doesn't work, okay? So no matter how I try to do this, it doesn't work. Uh, so, oh, sorry. This should be, okay, never mind. Sorry. Give me 1 second. Okay, this should be a class. Sorry. So, uh, wait a second. Um, is this, uh, it's very interesting. Okay. Uh, okay. Okay, sorry. I'm not sure why it's not showing up here. Um, okay, but the point is that, sorry, take back what I said. At states do not work with classes, not value semantics. They do not work with classes. It's so, yeah, I'm not sure. Okay, I think I need to I need to initialize it to something else. Okay, there we go. So let's do this. If I set the title to high, set the author to be unknown, for example. And then what else do we have here? We have is available. Okay. So let's try this. Okay, there we go. So when I click on this, nothing happens. There we go. So at states do not work with classes. They don't work with reference semantics. So to circumnavigate this, I could annotate this class as an at observable. And again, you could right click on this macro to expand it. I think you might also need to import the observation framework there. And then if you click on expand macro, you could see all of the code that the compiler has injected within this class for us. And that allows us for this books, for its properties to be observable, to be tracked. So let me just hide all of these. Okay. So now when I go back to the content view, and if I try to click on this, it should update to JK Rowling like that. Okay. So the at observable macro allows us to use at state on reference semantics, on objects to conform to reference semantics, like this book. Okay, so that is the demonstration between why reference semantics don't work with at state. Now, let me just go back to what we had before. So before here, we have a list of all of our books in our library manager. So if you take a look at our library manager, is a class and it is an at observable. So this is a class that can be observed. We could use it with at state. And so within here, I create our books within here. And then here we have two computed properties, and we have two public facing functions. And so again, this is our view model. And our view model is basically it contains all of our data for our books or any data that is system wide for our app. And it has these public facing endpoints that our view can tap into to either modify the data here or do some operation. So for example, here we have add book, we have remove book, and then here we have other properties here. Now, these are what we call compute properties. These are properties that belong or under library manager, but they compute their values on the fly. So right here, for example, is a computer property called available book count and returns an integer. And what we're doing is that we want to basically get the number of books that are available. So what I could do is that I could use books.filter, and then for this closure right here, I'm basically saying I want to filter all books that are available. Okay. And then it's going to give me a new array of books where it's each book's property is available property is true. And then I just get the count of that. So here's another example of compute property called books with titles longer than 4 characters. And this returns an array of books. So here I have what I'm doing is that I'm filtering on books where its title's length is greater than 4. So this is really cool because when books updates, these computer properties will also update as well. Okay, so you're able to create properties that it derives its values from other properties within the class. Does this make sense? Okay. So back into our content view, we have our list, and we're displaying our library manager.books here. And then now the error here is that because list requires each book to conform to identifiable, we could do that, and we just simply conform this to identifiable. Oops, sorry, not here. On the book itself, like so. And then it should be all good. Okay, there we go. And so this is our current view that we have so far. So we have, again, we're just basically displaying the book's title and then our library item book view, which is right here. And so our library item view takes in our book that for each book in the list, and then it just passes on to book view. And book view is simply, again, it's just some UI that displays information about that book. It's just a sample book title, an edit button, and then it basically has information if it's available or not. Uh, cool. Let me see why this isn't. Okay, there we go. So we have a list for each of our books, and here we could see that we could add additional books down here as well. Again, this is really bad UI. This is just for demonstration purposes. But yeah, so you can see here we have a library item view, and then its subview is a book view. So remember how we talked about forming dependencies? This book does not or this book view right here does not form a dependency with this book because it's not reading one of these properties. It's not reading book.title, it's not reading book.author or whatever. So whenever book.title changes, this does not get re-rendered. Okay. So it's able to bypass some of the views if there are no dependencies. But in book view, you can see that we are reading book.title. And so here it gets re-rendered, but not at this level. So that's how SwiftUI is able to efficiently re-render views without having to re-render whole entire view hierarchy. It only re-renders views if there are dependencies. So for example, book.title, book is available. So when you're reading properties, that's where SwiftUI kind of re-renders. So with this observable object here, it just bypasses here if one of book's properties changes. So let's take a look in our book view right here. This is, again, really simple UI. This is just the this first row right here, and then here just simply showing the checkout information if it's available or not. So here I'm just going to add back book is available toggle. And as you can see, we're able to just simply pass the book down to each subview. So again, we're getting each book here from this list. We're passing it down into library item view right here, and we're passing that book into book view right here. And now we couldn't do this before, right? We couldn't do book, if we try to change, for example, book is available dot toggle. So what this does is that if book is available is true, it just changes to false. And if it's false, it changes to true, right? We couldn't do this before because book was a struct. It conformed to value semantics. So when we were passing each book down, if book was a struct, if we're passing it down into each subview, it made a copy, right? But since book is a reference type, it's a class, we're passing a reference down to each subview. So when I do book is available.toggle, it actually modifies this or one of these books is available property to the new value. Okay, so it's actually modifying the is available property, for example, to this book. Does that make sense? Okay, so that's why this is possible. Okay, so if I go back to the content view, for example, and let's try, checking out this book, you can see that it reflects right away. Okay. And now let's add back our book edit view. So I'm just going to add a book edit view right here. And so let me just comp this out again. Okay. So here's a book edit view, and it just has a text field and it has a toggle that toggles the book's is available property and the text field that changes the book's title. Now, here again, we're passing our book into book edit view. Now, text field expects a binding. So when I do option click here, okay, it's not really, okay. So I'll go to the documentation and I do text field here. There we go. So you can see that it expects a binding. It expects a binding string, right? So the text argument here, parameter here is a binding string. So if I just did book.title, what what's okay, it shouldn't work, but what type is book.title? What does this mean? What type is this? What type is book.title? Yes. It's a string, right? But what do we want? But what does text here want? It wants a binding string, right? So I can't do this, right? It says cannot convert type string to expected argument binding string. So how do we do this, right? Again, this is an observable object. So what we could do is that we could use the bindable property wrapper in which it treats this book like a binding. And then here I use this $sign in front. And this right here is a binding string now. So when the user types in the text field to change the book's title, it's directly writing back to the book's.titles property. Okay, does that make sense? Yeah.
So bindable is for classes, and binding is for just. Okay.
That's correct. So bindable is for observable objects, which is in this case our class, and binding is for value types. Okay, like structs or integers and so forth. Okay. So now here's the same thing. This toggle right here expects a binding, right? Because internally SwiftUI right? When it's changing that toggle, it wants to change, it wants to, you need to pass in data or some variable into it so that it changes the value of it internally, right? So we need a binding so that it can write toggle can write back to this data right here. And so when I change the toggle, it's actually changing the is available property on our book. So if I go back to our content view right here, and let's do edit. So this is our sheet that we have. And we can now type. I don't know why my keyboard does not work with the previews for some reason. Um, it should work, but like on your end, I don't know why it was not working for me today. But I could toggle the book is available label here. So now, okay. Now another issue is that when I click this close button, it does not work. Okay. So the reason here is that when I click the close button, I want to dismiss the sheet that I have presented. The way to do this is that you can get the dismiss function from book edit views environment. So to do that, I do environment. I use the environment property wrapper, and I could use this key path notation with the slash dot, and I can access a lot of different information of this view's environment. I can get access if it's in light or dark mode. I can get access to accessibility stuff and so much more. So the one I want is the dismiss keyword, and then I basically get this as a variable. And then within here, I just do dismiss. I just call this function like that. Okay. So now when I go back to my content view, I should be able to dismiss my uh, sheet that I presented. So if I make this book not available, you can see that now it says waiting for return. So when I toggled it, right, it's changing the is available property on that book. And what it's doing is that, our books are stored here in my library manager, and it's actually changing. For example, if it was the first book. So it's changing this book's is available property to now be false. And then since it's observable, right, everything in my content view and the book view, right, it reflects the new data with waiting for return and so forth. Okay. I can add a new book. And what that did was it added into here, right? Add a new book to here. So yeah, that's kind of how you do MVVM. So again, you abstract all the logic of storing your main data into this view model, and you expose the properties and functions so that your views can get access, can your views can get access to these functions and properties. Okay. So before we go, I just want to really quickly show you how do you pass, I guess, objects down into a lower subview. So again, right now we're basically passing this book, down one by one by one. But what we could do is that we can simply pass. Okay, so right now our library manager is here, right? It's stored in content view. What if I want to get access to library manager in our book edit view? So what we could do is that we could pass this library manager as an environmental object. So on my library item view, I could do environment, and I could just pass in my library manager like that. And I injected the library manager into library item views environment. So I can get access to the library manager within library item views environment. I could also get it within book edit view as well, because book edit view is a subview of book view, and book view is a subview of library item view. And so to get back that library manager, I do environment, and then I basically specify the type of the object I passed in, which was library manager.self. So this is how you specify the type of something. So library manager.self, and then uh, get it as a variable like that. So now I can use library manager here. I could, for example, I could create a list of library manager.books here, just like that. And so that's how you could bypass, you know, putting a variable or an instance down each subview where you could just inject it into one of the subviews environment and you can get access down to it like that. Okay. Really quickly, another thing I want to mention is that within your project, you might see this file that Xcode creates for you. And this is a special struct because this is the main entry point into your application. So when your app gets first run, this is the first entry point. Okay. So it's not a view, it's an app. And it has a window group that wraps around the content view so that, for example, if you're an iPad, you might generate multiple window instances of your app